Today we're going to talk about domain of a function. So when you're talking about domains, what you're really talking about is all of your x values. Okay, so domain refers to x values. And really there's two things that you want to keep in mind here, that math does not like undefined numbers, and the imaginary unit I. When we're talking about domains, these are really two situations that we're looking out for. Okay, so for an example, let's say we're given the equation f of x equals negative 2x plus 1. So just thinking about numbers that I could plug in for x that are real numbers, there's nothing in here that I can plug in for x that is going to result in either getting something undefined or something imaginary. Okay, you could stick whatever number you want, irrational, rational, it does not matter. You're always going to get a valid answer here. So here we say our domain is all real numbers. Another way you might see that is the double R. Okay. So for something polynomial like this, we're pretty safe to assume that they're all real numbers, because there's nothing really that you could put in here that's going to result in one of these two situations. Okay, let's look at an example where we have to be a little more careful. Okay, so let's say I'm given a function g of x equals x over x squared minus 1. Okay, so really my concern here is that any number I plug in for x is not going to result in a 0 in the denominator. So the way we solve for domains to describe them, we're going to take our denominator, x squared minus 1, and we're going to tell ourselves that that cannot be equal to 0. So the not equal sign right here. And then we're just going to go ahead and solve this like we normally would. Okay, so let's add 1 to both sides. So here x squared cannot equal positive 1. This is square root method. So putting a square root on both sides cannot equal plus or minus the square root of 1. Okay. So the square root of x squared just gives me x. That still cannot be equal to plus or minus the square root of 1. And we know the square root of 1 is positive 1. I still have my plus or minus signs out here in front though. So really I'm looking at x cannot equal negative 1 and x cannot equal positive 1. Okay, so looking at these two values, if I were to plug 1 up into my original equation, the denominator here I'd have 1 squared minus 1, that would give me 0. That's something undefined, so we don't want to use it. And the same thing here, plugging in negative 1 in for x would give me negative 1x squared. That is just positive 1 minus 1 would still give me 0 in the denominator. So here, I can use any other real number except 1 and negative 1. So we're going to describe our answer in set builder notation. Set builder notation uses braces. We say x such that x cannot equal negative 1 and x cannot equal positive 1. Okay. Let's go ahead and look at another example. This one will have square roots in it. So let's say, for example number 3, I'm given a function h of x equals the square root of x minus 5. Okay, and just remember, we're looking for one of these two situations, 1 over 0 or square root of negative 1. Okay, so I'm not really concerned I'm going to end up with 0 in a denominator because I'm not looking at anything rational here. This is just linear underneath the square root. So I am concerned about imaginary numbers. Okay, so I want to make sure that whatever value I plug in here for x is going to be a positive number. Okay, I want this to be 0 or bigger. I can take the square root of 0. So I'm going to take what I have underneath my radical, x minus 5, and I'm going to say that this has to be greater than or equal to 0. And again, I'm going to go ahead and solve this like I normally would. So adding 5 to both sides, that tells me x is greater than or equal to 5. Okay, so if it was 5, I'd have 5 minus 5, so I'd have the square root of 0. Square root of 0 is just 0, so we're good there. If it was 6 that I plugged into my equation, I'd have 6 minus 5. That would be the square root of 1. The square root of 1 is just 1, so we're good. Now, if I had negative 1, so if I plugged in negative 1 in for x, I'd have negative 1 minus 5. That would give me negative 6, and we'd be back over here with imaginary numbers. Okay, we don't want to take square roots of negative numbers, so we avoid them when we're searching for the domain. So here, in set builder notation, our domain is x such that x is greater than or equal to 5. Let's do one more example with domains. What happens if I have a square root in the denominator? So let's say I have the function f of x equals 3 over the square root of x plus 1. Okay. Well, unlike the previous example that we did, here this square root could be equal to 0. Here in this example, since it's in the denominator of a fraction, I cannot have this to be equal to 0. Okay, and I still don't want this to be negative either, because I want to avoid imaginary numbers. So we're going to just take the terms underneath the radical, x plus 1, and we're going to set that strictly greater than 0. So then we're going to solve like we normally would, minus 1, minus 1. That tells me x is greater than negative 1. Strictly greater than negative 1. Okay, so because I don't have greater than or equal to, I only have the greater than. That means when I'm selecting values, I can't use negative 1. It has to be bigger than negative 1. So if I was going to pick 0, here I'd have 0 plus 1, which would be the square root of 1. And I'm okay. I don't have a 0 in the denominator. I'm not ending anything imaginary either. So we're good. So here we're going to say our domain is x such that x is greater than negative 1. And I am done.